equation, solve for that one letter, plug that value in for that letter in one of the two equations we have with two letters, solve for the second letter, plug those two numbers into one of the original equations, solve for the third letter, and check. Now, I've just gone through that fairly rapidly, but we're going to go through a couple of problems here. I just wanted you to get an idea as to where we're heading. So let's take a look at the first visual. The first visual has three equations, each with an x, a y, and a z. The equations are numbered 1, 2, and 3. When we produce the other equations with two variables, we'll call those equation number 4 and 5. By numbering the equations, we can keep track of what we're doing. Because again, with three equations and three variables, there's a lot of work involved. And you want to be able to go back and see what you did where. Now, looking at those three equations, which letter would you choose to eliminate? You have a choice. In my introduction, I said we could eliminate z. You can eliminate y if you'd like. Eliminate x, whatever letter you'd like. But looking at those three equations, you'll notice that the z in equation 1 is a negative 1z. In equation 2, it's a positive 2z. And in equation 3, it's a positive z, positive 1z. So I think it would be really easy to eliminate the z's. And that's what I've chosen to do. So in the next visual, you can see I've written equation number 1 and equation number 3. Those two equations, immediately upon addition, will cancel out the z's because we have a positive z in equation 3 and a negative z in equation number 1. And therefore, there's no multiplication needed. That's really kind of easy to do. And we get equation number 4. Equation number 4 is highlighted on your screen. 3x minus 2y equals negative 1. We now have one of the two equations with two letters. We need to pair up another two equations. You'll notice at the bottom half of your visual on the screen, you'll see that I've chosen to take equation number 1 and multiply it by 2. Why did I multiply it by 2? Because then the negative z becomes a negative 2z. I'm going to add that to equation number 2, which has a positive 2z. By the way, I want to let you notice something. When you look at that visual, you'll see that we've written 2 times equation 1. When I did similar kind of multiplication at the board in the previous lesson, I used another kind of symbology. I put a 2 like with an arrowhead after it. Just two different ways to symbolize what you're doing. You pick the one you like, but on this particular visual, we decided to use this showing the equation number and showing that we're multiplying by 2. So we add those two equations, and in the last line, which is highlighted on your visual, you see that we get equation number 5, which is 7x plus 4y equals 15. Now what do we have? We have two equations with two variables. And in the next visual, we're going to work to eliminate one of those letters just as we did in lesson 11. And we have equation 4 and equation 5. And notice if we multiply equation 4 by 2, we now have a negative 4y. We already have a positive 4y in equation 5. So that when we add 6x minus 4y equals negative 2, which is twice equation 4, to equation 5, which is 7x plus 4y equals 15, we get 13x equals 13. And this is really simple because obviously we divide both sides by 13 and x equals 1. Now what do we do now that we have x equals 1? Well, at the very bottom of your visual, you can see we've taken equation number 5, which is one of the two equations with two variables in it, and we've replaced the x with 1. Why? Because x equals 1. 7 plus 4y equals 15, 4y equals 8, y equals 2. We now have two of the variables. We have x, we have y, we need to get z, and we need to check. Let's go ahead and do that at the board. Okay, first thing I want to do is write down my equation number 3, which was x minus 5y plus z equals negative 6. Again, as I've said in previous tapes, you may be in a situation, obviously you're doing this on a piece of paper, and the equation is on your piece of paper, but since I'm doing it at the board, I wanted to be sure to have the correct equation on there. X minus 5y plus z equals negative 6. Now, I need to solve for z. I know what x is, I know what y is. What is x? X is 1. Y is 2. And 5 times 2 is 10. and plus z equals negative 6. Remember, I can always solve an equation if I have one letter in it. And that's what I've got here, so it should be no problem. 1 minus 10 is negative 9. This is negative 6 still. We add 9 to both sides, and we get z equals 3. Now, I like this particular problem, and I've shown it to you as the first example because it shows you how easy this kind of problem can be. Because you'll notice that the answer is x equals 1, y equals 2, and z equals 3. So solving systems of three equations is as easy as 1, 2, 3. Except we're not done. And you can laugh, by the way, if you like, but you don't have to because I can't hear you. What? Somebody laughed. That's exciting. Okay, what we need to do now is to check, and we're going to check over here at the board also. So let's see, we have our answer, 1, 2, 3. I'm writing it up on top so I can erase all this stuff here. Now, what equation do we use to solve for the last letter? We used equation 3, so we're going to check in equation 1 and equation 2. If you want to check in equation 3, that's fine, but it really isn't necessary since we've used it to solve for the last letter. Equation 1, 2x, which is 2 times 1, plus 3y, which is 3 times 2, which I believe is 6, plus z, minus z, it's minus z, is minus 3. And that's supposed to equal 5. That's the original equation. It was equal to 5. Well, let's see. 2 plus 6 is 8. 8 minus 3 is 5. Equation 1, could have put a check mark next to it. Equation 2, we have 3x. 3 times 1 is 3. Minus 2y. Well, let's see. Y is 2, so it's minus 2 times 2 is minus 4. And plus 2z, plus z, equation 2 is plus 2z. I was correct, plus 2z. Z is 3, so it's plus 6. And that's supposed to be equal also to 5. Well, let's see. Is it equal to 5? 3 minus 4 is negative 1, and negative 1 plus 6 is 5. So it's checked. We are correct. And as I said before, doing this kind of stuff is as easy as 1, 2, 3. Now we're going to give you a chance to prove that you can do it as easy as 1, 2, 3. I'll give you a hint. This next problem, the answer is not 1, 2, 3. In fact, I don't think the answer is even negative 1, negative 2, negative 3. But let's look at the next visual, which gives us the three equations. Okay, we have the three equations, and I want you to copy them down, then stop the tape, and solve. If you need a little help, what you might do is not go ahead in the tape, but rewind the tape and walk again with me through the solution I just did. If that doesn't help, then you'll go ahead and run the tape, but I prefer you give it a real good try at solving these three equations. I've already labeled for you 1, 2, and 3. So at this time, go ahead and stop the tape, and when you're ready to solve the problem, we've gone as far as you can go, turn the tape back on again. Okay, well, hopefully you've made the effort, and hopefully you've got the correct answer. And we'll find out if you got the correct answer by looking at a solution that I'll do for you. The question, of course, is you may have done it a bit differently. I have chosen, in fact, to initially eliminate the y's, I believe, and you may have decided to eliminate the z's or the x's. That's up to you. It's not important which letters you eliminate. What's important is that the answer at the end, the x, y, and z, are correct. And of course, we know that if we check. So let's take a look at the next visual, which is, pretty much fills the screen with stuff. But again, solving three equations with three variables involves a good deal of work. And that's why it's very important to do it quite carefully. And what I've done here is I've taken equation 1 and multiplied equation 2 by 2. And adding those up, I get equation 4, 8x plus 13z equals 16, eliminating the y's. I've then taken equation 2 and multiplied it by negative 3, and added that to equation number 3. and wound up with equation 5, which is negative 4x minus 17z equals negative 8. So we now have two equations, two variables, x and z. And what do we do now? Well, the next visual should show us. We've taken equation 4 and written it down. 8x plus 13z equals 16. And we've taken equation 5 and multiplied it by 2, because notice the coefficient of x in equation 5 was negative 4. Multiplying it by 2, it gives us negative 8. So that we add those two equations, we wind up with elimination of the x. So we have that shown. We eliminate the x, we add, we get negative 21z equals 0. And I guess I messed up because I probably should have wanted to get a positive 21z, but that's okay. It works out really nicely because you can notice that when I divide both sides by negative 21, 0 divided by anything is 0 anyway. So z is equal to 0. Again, 0 certainly is a possible answer, and there's nothing wrong with that. All right, now what are we going to do? We're going to have to solve for the x and then solve for the y. And highlighted on your screen is equation number 4, where we replaced the z with 0. Equation number 4 was 8x plus 13z equals 16. 13 times 0 is nothing, so we have 8x plus 0 equals 16. 8x equals 16. X must equal 2. Okay? So now we have z and we have x. We can go back to one of the original equations, and I've opted to go to equation number 2. In equation number 2, we have 3x, 3 times 2, which is 6, plus y, we don't know what y is yet, minus 2z. And of course, minus 2 times 0 is the same as plus 0. And that's all equal to 3. And we go ahead and solve. We get y equals negative 3. So we now have our solution. We now have our solution, which is x is 2, y is negative